Alright, so we'll try this question. X plus 5 all squared plus an x plus 5 times an x minus 5 all over 2x. So what we're going to do first is try to simplify the top before we divide, because that's a bit of a mess up here, and that will simplify down. So I'm going to start with my x plus 5 all squared. And can you all remember how to simplify that? So the common mistake is to kind of stick that squared in on top of both of these numbers instead of saying, hold on a second, that's a squared on a parenthesis, so it actually means this thing times itself, right? Because if you just stick a squared and get like x squared plus 25, that's just not the correct answer. Did you all know that? So that is probably the biggest mistake there. So my point is that we're actually supposed to do this, and let me explain why. Because so what we do not do is just call it x squared plus 5 squared, which is x squared plus 25. Okay, so that's what we don't do, and the reason is because, like, if x was something like 10, so let's say it was 10 plus 5 all squared, which by the way is 15 squared, and 15 times 15 is 225, I think, or 5 carry the 2, 7, 0, 5, 1, 225, right? So that the answer should be 225, and if we just say it's 10 squared plus 5 squared, we don't get that, because look, we get 100 plus 25, which is 125, which is wrong, because it should be 225. Does that make sense? And in fact, I can't even stop myself, because look, 10 plus 5 times 10 plus 5 is actually what it is. Of course, you could have just added here, because these are like terms, and got 15 and then squared it to get that. But if we did the double distributive property, watch this: 100 plus 50 plus 50 plus 25. And now we've got our 100 plus, look at that, another 100 plus 25. That makes 200 plus, sorry, why am I writing this all out? 225, right? So that is why we do it that way. And I'll come back to that, because this multiplied out looks a lot like multiplying out to 10 plus 5. Anyway, so the double distributive property means we go this times this, then this times this, we get x squared plus 5x, and then this times this, and then this times this, plus 5x plus 25, right? And so we get x squared plus 10x, and that's adding like terms, plus 25. And then we're done, because these things are not like terms, right? And that's actually very similar to my quick example of the 10 plus 5, because look how we ended up with, 100, which is basically 10 squared. Look, it's kind of like x squared, right? Plus 10 tens, right? Which is our other 100, plus 5 times 5, plus 25. See how these answers are actually very, very similar? Instead of x, I put a 10 and I got 10 squared, so they are the same thing, right? So instead of x, I have a 10, and look how the 10, it's 10 squared. See that? Plus 10 times 10, right? But in our example, we just had x instead of the 10. So anyway, if that explains why you need to expand that and not just write x squared plus 5 squared, I hope that explains it. But that really is probably the key to this problem. If you got that down, I think there's one more step. But x plus 5 times x minus 5. Everybody watching from home, please press pause on the video and try that one yourself. Press pause and try. So we're going to take this, multiply this by this, and then multiply this by this. Okay? So x times x, x squared. Okay? X times negative 5 gives what? Good. Okay. So then take the 5 and multiply it by this, and then take the 5 and multiply it by that, and write down what you get. Good. Good. So that's it. So plus 5x minus 25. Okay. So we got that far. Now add like terms. Take your time. Add like terms. Yeah. Right. So negative 5x plus 5x is, well, it's 0x or 0. It's nothing, right? So that makes 0, right? And so that goes away, so to speak, and as you say, we get that. Perfect. Good. So what we have now is we took this part of the top of the fraction and it became this, and then we took this thing and it became this. So if we put those together, at the top of the fraction we have x squared plus 10x plus 25, and then there's a plus there. See that plus? So plus x squared minus 25, right? So that's what the top of the fraction is. And by the way, it's all over 2x. I guess I'll put that in there. I don't have to, but I will. I'll just take my time. But so the whole thing became this. Are we clear on that? Okay, so let's write that out, and then we'll add like terms and see what we get. So, good. So the one, you've got an x squared here and an x squared here. That's like 1x squared plus 1x squared, so that's 2x squared. Good. Yep. Right, but it's 10x. 10x, yeah. Now 25 minus 25, like you say, that is 0, right? So it's 2x squared plus 10x all over 2x, right? Alright. Alright, so we've got 2x squared plus 10x all over 2x, right? So the last step is to remember, what do we do when we have different terms being added and we're dividing by something? Now, why do I need to think about dividing? Because we've simplified as much as we can on the top. As much as we can on the top. We simplified, we added like terms, see that? We added like terms, and it all wound up to be 2x squared plus 10x. And these are not like terms. So the 2x squared and the 10x are not like terms. We cannot add those together. So it doesn't make 12x squared or 12x or 12 anything, because they're not the same thing. They're different animals, different terms, right? Be kind of like having 2 millions and 10 thousands. It doesn't make 12 millions. You know, it's like, or 2 hundreds and 10 tens doesn't make, you know, 12 hundreds or something. It's they're not like terms. So anyway, so we've got to that point. They're not like terms. How do we divide? And that's going back to the whole, you know, if you had kind of, you know, 4 apples and 10 bananas, and you want to divide it equally among 2 children, what do both kids get, right? Right. So you got exactly 2 apples, 5 bananas. And the reason is because you actually have to divide the 4 apples amongst the 2 children, and you have to divide the 10 bananas amongst the 2 children. You can't just divide the apples and not divide the bananas. That wouldn't make sense, right? So you got to divide both, because this fraction bar is communicating that the whole thing is divided by 2. If they only wanted you to, see, most students will just divide this and they'll leave the 10x alone. But if they only wanted you to divide by the 2x squared, they would have written it like this, everyone. They would have gone 2x squared over 2x, then plus 10x. See that? Do you see the difference? See, this one has a fraction bar over everything. See that? It's all divided by 2x. This one just has a fraction bar here, right? So the reason that fraction bar goes all the way over is that they want this whole expression divided by 2x. All right. So just like the apples and bananas, we need to split these up. So that needs to be divided by 2x. Plus, this plus sign goes here, plus the 10x needs to be divided by 2x also, right? And so that's the key. That's the key. And then now we've got it. So take your time and calculate each of these. Good. Very good. Yeah. The answer is, you're right. 1x plus 5 or x plus 5. Same thing, right? This way or this way. They're both the same thing. 1x is the same thing as x. Good. Exactly. If anyone got stuck on this part, just do this. Watch. 2xx over 2x. The x's cross cancel. The 2's cross cancel. I'm left with 1 times x times 1 over 1, which is just x. Okay? So that might help there. But yeah, that's the answer. X plus 5. Good job.